Welcome back. Today we are going to crack one of the smartest searching technique in coding, the binary search algorithm, one of the faster and smartest searching algorithms. Introduction. Binary search is one of the most efficient searching algorithms. It is used to find the position of a target element in a sorted array. Instead of checking each element one by one like we do in linear search, binary search repeatedly divides the array into parts until the target is found. Earlier, I mentioned binary search only works if the array is sorted, whether ascending or descending. If the data is not sorted, binary search cannot be applied. Core idea behind binary search is first we start with the two pointers low and high. Then in the next step, we simply find middle index. In order to find middle index, we use the formula low plus high by 2. Then we compare array mid with the target value. If both values are equal, then that means that target element present in the array. If target is less than array mid, then we will search in the left half. Otherwise, we will search in the right half, and we will continue until target is found or search space becomes empty. Here is the step-by-step process. First, we set low pointer with 0 value and high with n-1. Then we calculate mid value, and then we compare array mid with the target, and accordingly we adjust search space, and we do repeat steps until found or low is greater than high. Here is the simple example. Let me explain this with the help of simple Java code. I have one class binary search example. In this class, I have one method binary search which simply accepts two parameters, array and target. Then I am initializing two variables, first left and then right. Left equal to 0 and right equal to array length -1. Then comes to while loop. Here I am simply checking the condition whether left is less than equal to right. If the condition is true, then only I am going to enter in this while loop. In the while loop, first I am calculating the mid index. Then I am comparing array mid with the target. If both values are same, simply I am going to return mid. And then if array mid is less than target, we will be searching in the right half. Otherwise, we will be searching in the left half. If that array element is not present in the array, then simply we are going to return -1. Talking about main method, in main method we have that array. The name of array is numbers with the values, and value of target is 23. That means we are going to look 23 in that array. Then we are simply calling binary search by passing numbers and target element. If that target element is present, then we are simply checking if result equal to -1. That means that element is not found, where otherwise it will print the index of that element. Here, the result of that code snippet is element found at index 5. If I talk about complexity analysis, binary search takes order of log n time because the search space is divided by 2 in each step, and space complexity is order of 1. If I compare with linear search takes order of n, where binary search takes order of log n. Advantages of binary search: it is much faster than linear search for a large dataset. It works efficiently on sorted arrays. It is easy to implement and widely used in coding interviews. But binary search comes with limitations. It requires sorted data, and it is not useful for unsorted or dynamic dataset unless sorted first. Here is some applications of binary search. First, searching in a large sorted database. Second, implementing search functionality in libraries and APIs. Third, use in solving coding interview problem. Here is the conclusion. Binary search is a powerful and efficient searching technique. It works by repeatedly dividing the array into parts until the target is found. It reduces time complexity from order of n to order of log n. That's for today's video. If you found this explanation easy, don't forget to like, share, and subscribe. Thank you.